Let's focus first on electricity generation. In the UK, 29% of our carbon emissions come from generating electricity. That's a huge amount and something we need to really focus on.
At the moment, huge amounts of fuel are wasted in order to make electricity. On average, for every 2.5 energy units of fuel that goes into power stations, approximately 1 energy unit of electricity is produced. Solar photovoltaics, or solar panels as they're commonly called, can be integrated into the design of a building or, equally, can be successfully fitted retrospectively with minimal disruption. This video is going to give you a thorough overview of how to calculate the size of system that you need, and also how to be confident in your calculations of financial and energy payback periods. Photovoltaics are made of 2 layers of semiconducting material, usually silicon. When light shines on the panel, it creates an electric field across the layers. Photovoltaics do work on cloudy days, but will produce more electricity in strong sunshine. The strength of a photovoltaic cell is described in terms of the amount of energy it generates in full sunlight. As this clip from the Energy Saving Trust shows, the panels produce direct current, DC, which is converted to alternating current, AC, by an inverter, so it can be used by appliances in the home, and the system can either be connected to the grid or to a battery. Photovoltaics were first created to provide electricity for orbiting satellites. The first solar cell was made in 1954 and cost 30 times the price per watt of today's panels, the prices of which are still reducing. The efficiency was initially 4.5%, whereas this has improved dramatically over time, and nowadays panels can be purchased easily with efficiencies of 15% to 18%. Under certain lab conditions, photovoltaics have been found to perform even as high as 38%. And by the way, the average efficiency of a coal-fired power station is around 30%, with even further losses occurring when this is transmitted to buildings. Monocrystalline panels are highly efficient, expensive, and are made from thin wafers of silicon sliced from large crystals that have been grown under carefully controlled lab conditions. Polycrystalline panels are cheaper to produce, but less efficient, and are made from a number of interlocking silicon crystals grown together. Both of these types are readily available and cost-effective ways of generating electricity and can easily be fitted retrospectively. More recently, amorphous panels are being produced, which are able to form any shape required. They're relatively inefficient and expensive, but with the advantage of flexibility. The silicon is deposited in a very thin layer onto a backing material rather than growing crystals.